What's the probability of drawing an ace from a standard deck of cards, 52 decks? See if you can calculate that probability. So look at your probability. What's the number? How many ways can you draw an ace from a standard deck? Abby, how many aces are in there?
4.
Right, and so 4 out of 52 cards possible reduces to 1/13. So not a very big probability of drawing an ace. All right, is it different for any other card? What's the probability of drawing a king? Do you see it's the same?
Yeah.
There's 4 kings, there's 4 twos, so any card is like that. All right,
Unless it's the Joker.
right.
That's
Then we'd have like 2 out of
54.
54. Wow, that's amazing. All right, let's do 2 dice. And this one gets a little tricky. You might need a little chart. And if you make this chart, you can always look back at it, at your problems, so it won't waste your time. What's the probability? We're tossing 2 dice. The probability of rolling, say, a 7. Sometimes you just count them. Like you can, when you roll, how many ways can we get a 7? We can do a 3 on the first die and a 4 on the second.
A 1 and a 6.
And we can do 4 and 3. So I'll reverse the order.
1 and 6.
1 and 6.
2 and 5.
6 and 1.
2 and 5.
2 and 5. 5 and 2. Is there any others?
7 and 0.
I think that's it.
No
I
7.
think that's it.
That's it? So how many ways? 1, 2, 3, 4, 5, 6. Let me see if I got that. 1, 2, 3, 4. It is right.
But then again, what is it over?
Yeah, how many
it's an
possible numbers?
Infinite possibility of combination.
There's combination. We can actually count them with our counting techniques. So there are, how many ways can we fill in the first box?
1, 2, 3, 4,
6.
And then the second box?
5.
And there's 6 again, because a number here can be repeated. So
So it'd
that's
be
up with
6,
36 possible ways.
So it's 1 over 6.
Yeah. There's 36 different combinations when you roll 2 dice. All right, we'll put together what we've learned yesterday and what we learned today, and then I'll assign you some problems and see how it goes. Actually, I didn't copy that paper. I have to go copy it. All right, let's say that we have a lottery situation. It's always good to know what your probabilities are when you buy those tickets or play those games. So let's do one. All right, again, this is going to take some thought because it's combining yesterday's and today's work, just like we used the combinations on this one. So write down this example. This is a game where you pick 6 numbers, and the numbers can range anywhere from 1 to 41. So you pick them. It's one of those kind of games. So one of those kind of lotteries. So write down the problem.
Which is a really low probability.
Yeah, we're going to see that.
Yes.
All right, so you're going to pick 6 numbers, and so for example, you might pick 2, 25, 7, 18, 33, and 41. So you could pick 6 numbers, and then the lotto guys, the guy who runs the game, he comes out and he picks 6 numbers. So you pick 6 numbers, the game controller picks 6 numbers. Now, if your numbers match his numbers in any order, you win. So this is
So now
maybe
we
he
can open
picks
the
7,
factorial.
18, 41, 33, 2, and 25.
Oh my gosh.
What, 25? 1, 2,
He's being
3,
really
4, 5,
lucky.
6. You're a winner, no matter what order he picks them. So this is gonna get tricky, isn't it? All right, I want
Because
you
then
to,
like 5 people could win, and then you
Fine.
split the money.
that's true. Find the probability. Yeah, you could have multiple winners. Find the probability of winning.
Do you have to do it over the factorial of 1, 2, 3, 4, 5, 6?
No, not quite. There is a factorial, a portion of a factorial involved. All right, so in this probability, let's start at the bottom. How many, is this going to be a combination or a permutation?
Combination?
Pardon?
Combination.
It is a combination, and Molly and Bailey, you were wanting a combination, but since the
Yeah.
order doesn't matter here, let's figure out how many combinations there are. So we have 41
Yeah.
items,
Over
picking 1, 2, 3, 4, 5, 6 at a time. So we have to calculate that. And we learned yesterday how to do that.
But what numbers do you plug in?
Pardon?
Is it just like 42, 42, 42?
It is. Because you,
41.
oh no, wait a minute, I don't
That's
think
fine.
you're not allowed to repeat numbers on this game.
Oh,
Okay.
you can't?
Yeah, so you couldn't
Oh,
have said 18,
so it'd be
18, 18, 18.
So
Yeah,
it'd be
Do we have 5
41,
boxes or 6?
40.
yeah, we need 6.
Okay.
40.
Sorry, thank you.
40.
Alright, so
40.
combinations are
39.
calculated just like permutations at first. So
40,
what number goes into this box, Molly?
41.
And then Bailey?
48.
Alright, you got it. So, and so on.
Maybe I'll subtract 1.
But then yesterday we
6,
learned the
5.
combinations are reduced. So what do we divide by? Do you remember, Abby,
6.
from yesterday?
The number of boxes.
Yes, factorial. Right. All right, so I need that number, so tap it out. Find that number. Bailey too.
That's a big number.
That's because your
we
chances are
divided
really low.
by 6 factorial, we know
And then
that.
keep in mind
What's
that
6
like a million
factorial? Is that
people are doing
720? Is that the 720 one?
I think so.
All right, so we don't have to use the factorial button.
I just do 6 times 5 times 4.
Okay, that's fine as well. All right, what you get, Allie? We'll test it against others.
4, 4, 9, 6, 3, 8, 8.
That's what I got.
4, 4, 9, 6, 3,
8, 8.
8, 8. All right, let's see if that's what I got. It is. So, how many ways can this event happen? How many different ways can you select a number, or how many numbers are you going to select?
6.
All right, so
So you have to divide that thing by 6. and
But
get
you
one.
are only going to buy one ticket.
Yeah, good.
You're only going to buy one ticket, and it's going to have your selection. So they said the answer was 1 over that.
That's a really bad probability.
Yeah, that is a
Oh,
pretty
so-
1 over 4 million. And that's only numbers 1 to 41. So if the state wants to really be careful, they can create a even larger probability in their favor.
Couldn't it be
All right.
possible for like a whole bunch of people to win and everyone to go home with like $5?
It's possible.
That would suck. I won the lottery for $5. On my 7th ticket. I got
Well, even when
$5.
you win, like all that money, you get taxed. Like
Yeah.
Mhm.
Yeah, so you get about half of it.
yeah,
So you
But
get,
it's
like,
still a
two-
lot.
And you spent
So
all
if
the
you-
money on tickets, so and you have to split it with all the other people who won. So when they say $1 million lottery, you might
Yeah.
get 1,000.
it's still
If
money.
you're lucky.
I'll take 1,000.
My dad buys the lottery tickets when it's up to like 50 million.
My mom would say, "That's $1 I have and they don't."
Wow. My grandmother.
That
my,
was her wisdom. Guess what? I've never bought one.
My great grandmother used to buy lottery tickets like all the time, and she was like, if I ever win anything, it's going to like the grandkids, which is like my family. So I was like, yes.
Alright.
Fine with me.
Alright, we'll continue new stuff on probability on Monday. I think I only need one more day to teach you what I'm going to teach you on probability. And so I will copy this page and we'll do a few. See if I only need one page. Find the probability. Alright, yeah. Okay, I'll be right back.
I have a very dumb question, Bailey. How do your glasses not get caught in your hair?
Bailey, turn off.
Because they don't have the little like clips on the nose.